if you think of the x-axis as a function, y equals 0. Okay, that's a constant function. So even though I never considered it as a function, it's really the way you want to look at it. And so if you have a function, for example, f of x equals 12x plus x squared minus x cubed, you can think of the x-axis as g of x equals to 0. Okay, this is the x-axis, right? And so if you want to find the area under a curve, you could just look at the area between this function and this function. And so that's what I'm going to do today. I'm going to look at it from a different perspective because we want to broaden our capabilities as far as finding the area between two curves, not just under a curve. Okay, so the way we do that, let me draw the picture of this graph so you can kind of see what's happening. And this is just a rough sketch. I know the function passes through -3, 0, and it passes through the origin, and it does something like this. Let's see here. It's not very accurate, but okay, this is f of x that I'm talking about, right? And your g is the x-axis. So I'll just put g of x over here. All right, so let's suppose that we want to know the area between, well, this shaded area here and then this shaded area here. Now, the last example that I did last time was we looked at a function, and remember we got 0 as our answer. I don't think I brought that with me. I didn't bring my notes with me, but we got 0 as an answer because this sort of behavior, this curve here was symmetric, and so the two areas canceled each other. Because remember I said at the end that if the area of a curve, if it's under the x-axis, then it's going to be negative, and so you have to take the opposite sign to find the area. So when you're looking for the area between two curves, and this case, one of them happens to be the x-axis, what we're going to do is, because this area, this curve, the f of x is under the x-axis, we're going to get the negative answer. And the reason is because you take the top function and you subtract the bottom function to get the area, okay? And when we had done the example, we had the top function and we were taking the antiderivative or the integral from, let's say, I can't remember what it was -1 to 0, I think, or -1 to 1. And so because we did it that way, we didn't take into the account the fact that the function was under the x-axis. But today, for section 4.4, we're going to be doing the same sort of problems. However, we're going to consider that now because we're just focusing on the area, not on the definite integral. And I'm probably talking too much. It's probably like, sometimes I do talk too much. So let me just get down to business here. All right, here we go. So because I'm going to get a negative answer here, if I don't do it correctly, if I just integrate from -3 to 1, I'm going to get this area minus this area. And I don't want that. I want to find the area, okay? I want to find this area and this area. So I'm going to treat them separately. And the way we find the area between two curves is we take the top curve. So we're going to go from -3 to 0, okay? This point has x equals to 0, and so remember the indices on the integral go from -3 to 0. Those are the x values. Those indices are always x values. And then we're going to take the top function, which is g of x minus f of x. And then we're going to add to that the area here, which is the integral from 0 to 1. You always go from left to right, so we go from 0 to 1. And this time, f is above g. So it's going to become f of x minus g of x. You see how I reversed the order? Because area is positive, and I've got to pick the correct order to get a positive answer. So this time I'm taking the top function minus the bottom function, so g minus f. And over here, the top function minus the bottom function, so f minus g. See how that works? Okay, so now I just need to fill in what f and g are. Of course, g is 0, so this becomes the integral from -3 to 0 of negative f of x plus the integral from 0 to 1 of f of x. And that's just because for this particular example, g of x is 0. All right. Now the negative f of x, I'm just going to change the sign on each term. So it becomes negative 12x minus x squared plus x cubed. And then which is common, I forgot my dx is here. You always have to have dx when you integrate. So dx, dx, dx. It's a common thing to forget that. And now I take the positive f of x, so it becomes 12x plus x squared minus x cubed dx. There we go. So we're calculating these integrals to find the area. Now, to remind you, the way we calculate the integral, we want to find the antiderivative for our function, and we add 1 to the exponent and divide out by the new exponent. So here I'm going to add 1 to 1, so I'm going to get negative 12x squared, and then I have to divide out by 2 because that's the new exponent. Here I'm going to add 1 to 2 to get 3, so it comes minus x cubed, and then I divide out by the new exponent. Then we're going to add 1 to 3 to get 4, and then divide out by 4. And then we're going to evaluate that from negative 3 to 0. Same thing here. The only difference is we're going to have different signs because this is just these are the opposite signs. But it's the same procedure. You're going to have 12x squared divided by 2 plus x cubed divided by 3 minus x to the 4th divided by 4. And this time you're going to evaluate it from 0 to 1. So now at this point, it's just a matter of plugging in these numbers. You plug in the top value, calculate that. So you can see when I plug in 0, this is going to be 0, 0, 0. Then, so everything's 0. Then you subtract what you get when you plug in the bottom value. So I'm going to subtract negative 12, negative 3 squared divided by 2, and that of course is negative 6, minus negative 3 cubed over 3 plus negative 3 to the 4th over 4. Then I'm going to add to that, okay, plug in 1. Of course, plugging in 0 gives me 0, so I don't have to worry about this one. I'm just going to add whatever I get when I plug in 1. So that's 6. So I get 6 times 1 squared plus 1 cubed minus 1 over 3 minus 1 to the 4th over 4. All righty. So this becomes negative 9 squared is 9. And then negative 6 times 9 is negative 54, but I have a negative out here, so this becomes 54. Then I've got negative 3 cubed. That's going to be negative 27. Divided by 3 is negative 9. This is going to change the sign to a positive 9, but this changes it then to a negative 9. And then we have negative 3 to the power of 4. That's going to be 81 divided by 4. Now we're going to add to that 6. Wait a minute, did I forget something? Oh yeah, I forgot this negative out here. So it's actually going to be negative, subtract 81, because we've got, this is positive, but then we have to distribute this negative here. So yeah, that's negative. Then over here, 6 plus 1/3 minus 1/4. And I'm pretty sure when you do your homework, they want you to leave it as a fraction. So I'm going to go ahead and find a common denominator. So you can see here that we have 4 and 3. So our denominator is going to be 12. So I'm going to, well, first, let's see here. Let me just combine this first with the minus 1/4. Anyway, I think I'm just going to save time, I'm just going to tell you what I got earlier when I did this. I'll let you work on that. But if you multiply by 12 over 12 and 12 over 12, and then here 3 over 3, 12 over 12, 4 over 4, 3 over 3, you're going to get 370 twelfths. And then when you factor out the 2, you get 185/6. So I'll let you, I don't want to take too much class time doing that out, but you do need to get a common denominator as I've done here. And this is what your number is. All right. Okay, so the main thing, let's review what we've done here now, because there's a lot of stuff going on here. So I just want to kind of review. So we want to find the area in green here, which turns out to be 185/6. Now, if I just integrate, in other words, if I calculate the integral of this curve here, like we did last time, remember a lot of the examples in 4.3 where we were just calculating the area under the curve, we integrated. The problem is this area dips below the x-axis. So we can't just go from -3 to 1, otherwise we're going to get this area minus this area. So we have to separate these into two integrals. So we integrate from -3 to 1, and then we take the top function, which is 0, g of x is the x-axis, so it's 0, and we subtract the bottom function. That's why we get the opposite sign here, because when you just calculate the integral of f of x, you're going to get a negative answer, and we want a positive answer for area. That's why we take the negative of a negative. Now here, however, the function is above the x-axis, so you just integrate your function. You don't take the negative. So we go from -3 to 0 to get the left area, and from 0 to 1 to get the right area. And then we calculate our integral, and it's pretty simple. You just add 1 to your exponent and divide out by your new exponent. So here the exponents are 1, 2, 3. We get 2, 3, 4. Divide out by 2, 3, 4. Okay? And that's how you do it. Any questions on that? All right. By the way, I'm just taking these straight from your homework. So the one that I did there, I think was from homework 1 or similar to homework 1, I think. This one isn't like another problem. I'm not sure what number it is, but you'll see it. It says find the area between f of x equal to x to the 4th minus 8x cubed plus 21x squared, and g of x equal to negative 22x plus 120. So we have two functions. We want to find the area between them, and they give you a picture to look at in your homework. All of these homework problems have pictures for you to see, graphs of the functions. So I'm just going to go to Desmos, and since sometimes it helps you to see that better rather than looking at my picture. So if you're using Desmos to do this, you are going to type in f of your function y equals, and f was x to the 4th. Don't forget this little tab down here will help you get your exponents. Minus 8x cubed plus 21x squared and then g of x is negative 22x, so I'm going to go y equals negative 22x plus 120. And you can't see both functions, so we're going to have to kind of, let me just collapse all this stuff here, and you can see we need to get it in the right frame. So I'm going to zoom out here, and it's kind of hard to look at. It's all scrunched up here. So I'm going to spread out my x-axis. Notice here that I'm going from 0 to negative 50, and I want the whole screen to be from like negative 6 to 5 or something like that. It's shifted off a little bit. So if you see this little toolbox up here with a little wrench sign, and it says x-axis, I'm going to change this. Instead of negative 257, I'm going to put negative 6 in there. And then over here, I'm going to put 5. And now we can start to see what we're looking at here. Okay, so that's just a little hint there for how to deal with that. I'm going to zoom out here. Okay, now, so we can't find the area between on this side because you can see it goes off to infinity. This goes up forever and down forever. And then same thing over here, they separate. But here is the area between the two curves that we can calculate. And if you look at this point right here, this is negative 2, 164, and focus on the x value. So it's negative 2, and then over here, this point is 3 for x. And so you're ranging, your integral is going to run from this point where x is negative 2 over to 3. That's what our indices are. And so they're going to calculate the area in between the two curves. But you have to be careful and make sure you subtract in the correct order, because you're going to take the difference of the two functions. So you're going to take the top function and then you're going to subtract the bottom function. And that will give you the area in between. And you can see my top function is the linear function, which is the f of x, and the bottom function is the g of x, which is the polynomial. Or it's the other way around. All right. So I'm just going to draw a quick sketch to remind us of what we're doing. We have this linear function, and then we have a curve that does something like this. I don't know exactly what. This point here was negative 2, 164. And over here, this point is 354. Okay. So we are finding this area in between. And the linear function is our g of x. This is g. And our polynomial function is f. All right, so we're going to take g minus f. We're going to take the integral from -2 to 3. And just remember, these indices are always x values, okay? And we're going to take g of x minus f of x, and we're integrating with respect to x. That's the area that we're looking for. Okay. So we have negative 22x plus 120 minus the entire function. Don't forget your parentheses because you've got to distribute that negative or you're going to get the wrong answer. So x to the fourth minus 8x cubed plus 21x squared. And we're integrating with respect to x, dx, okay? And I like to write my function in descending order, you know, in standard form for a polynomial. So I'm going to start with the higher degree terms when I do this. That's just my personal preference. I'm going to distribute this negative, so it's going to become negative x to the fourth plus 8x cubed, right? I'm distributing this, and we have a double negative there, minus 21x squared. And then we've got the negative 22x plus 120 all times dx. Okay. Now, I'm going to do the integration. So I'm going to be adding a 1 to each exponent. Here, you can think of this as x to the 0, right? Just imagine this is x to the 0. So when you add 1, you're really adding 1 to 0, right? So here we have negative x to the 5th power divide out by 5 plus 8x to the 4th power divide out by 4 minus 21x cubed divide out by 3 minus 22x squared divide out by 2 plus the 120x. There's my antiderivative of this function, and this is a definite integral, so I'm evaluating from -2 to 3. So this whole thing is going to be evaluated. And this just means you're going to take 3, plug it in, and then you're going to subtract whatever you get when you plug in -2. So I'm going to go ahead and do that now. By the way, I'm just going to go ahead and simplify this. This cancels and that becomes a 2. This cancels and that becomes a 7. This becomes -11, okay, like that. So we're going to get -3 to the 5th over 5. And by the way, this negative, there's a lot of confusion with this. This negative is not raised to the 5th power, it's out front, right? We're only raising 3 to the 5th power, so be careful. Of course, when you have an odd power, it doesn't matter, you're still going to get the same answer. But if it were an even power, it would make a difference. So you got to be careful with these when you're plugging these numbers in. Here then we get plus 2 times 3 to the 4th over, no, that's, yeah, 2 times 3 to the 4th because the 4 cancels with the 8. Then we have minus 7, 3 cubed, minus 11 times 3 squared, plus 120 times 3. And then we're going to subtract from that -2 Okay, so negative 2 to the 5th over 5. So let me, just to avoid confusion, let me put brackets around here. We're subtracting the whole thing when we plug in negative 2. So yes, we do have 3 negatives here. This is negative 2 to the 5th is negative 32. Then you have a negative becomes a positive 32. Then another negative becomes a negative 32 divided by 5. So, you know, it can be tricky with all these negatives. So plus 2, negative 2 to the 4th, minus 7, negative 2 cubed, minus 11, negative 2 squared, plus, that's going to be 360. So make sure you use when you enter this into your calculator, make sure you use the proper parentheses, and I'll let you try that out. The answer that you should get is 375. Okay. Any questions there on that one? Okay. Let me do, this is another one from your homework. Okay. Find the area of the region bounded by the graphs of the given equation. I'll just say find the area. Find the area. And we're given y equals 9x, y equals x cubed, and then we're given x equals 0 and x equals 3. These are just here to tell you what the how you're integrating, what the indices are. Okay, so you're going to integrate from 0 to 3. These are vertical lines, right? The functions that we're integrating is we're going to take the top function minus the bottom function. So a graph is helpful, and you can use Desmos. When you graph this, it looks something like, well, you've got your linear function here, and then you've got your cubic function, something like that. So you're going to be finding this area here. And this point here is when x equals 3 and y equals 27. That's the intersection point there. So you're integrating from 0 to 3. That's why they give you x equals 0 and x equals 3. You're going this way, as opposed to the area. If you just said graph the area between the curves and you didn't specify from 0 to 3, then you would have had some area over here because they intersect again. So this is the area they want. And that area is equal to the integral from 0 to 3. Now we take the top function. This is the 9x. The line is 9x. And then we subtract the bottom function, which is x cubed. And then we can't forget our dx. So you're going to add 1 to the exponent. So you're going to have 9x squared divided out by 2. And then you're going to have x to the 4th and divide out by 4 and evaluate from 0 to 3. Then you plug in the top number. You get 9 times 3 squared over 2 minus 3 to the 4th over 4. Subtract. When you plug in 0, you're just going to get 0, of course. I'll write it out here just to show what we're doing. And of course, you're subtracting the whole thing, which is just 0 anyway. So this becomes, okay, so 3 squared is 9. 9 times 9 is 81, so it's 81 halves. And then 3 to the 4th power is 81, and then, so we're subtracting 81 fourths. So to combine these two fractions, we get 162 fourths minus 81 fourths, which is just 81 fourths.